I'm really honored to be here and speak with you today. And the last talk was a really good primer on what we're going to talk about today. Um, can you see my screen hopefully okay here? Just a little bit about myself here. For those of you that don't know me, I have a background in biochemical engineering and stem cell research, and basically spent nearly 20 years in stem cell research and bioprocessing before moving into the aesthetic medicine world, previously working for Pfizer, Becton Dickinson, and others. After doing my doctorate in the UK, I returned home to California to do my postdoc before going into biotech and spending a lot of time working on translation of stem cell therapies into the clinic. Um, I know we have a limited um, oh, limited time here, so I'll go through this fairly quickly. So first of all, why do we need an effective post-procedure product? I think this is my co-founder here, Dr. Tim Syed, showing the power of the cynosure potenza. And you can see on this patient as he moves across her face some erythema. And so this redness is a common issue with a lot of procedures done in practice. And so you can see as that redness develops, a lot of folks don't want to go out into the world like this. They say, okay, you know, I need some social downtime. I need to take a break before going out. And, you know, this is just really where exosomes in general have made their mark initially. And we're going to talk a lot about exosomes, specifically about kind of what I call generation 1, 2, and 3 exosomes, because there's been some evolution over time of the different types that are available. But you can see here on the left, this is someone who just had a procedure done, immediately post-procedure, very red. And on the right, this is the patient we just saw. And as that line moves across her face, the difference between those photos is about 2 hours. And that's after application of our Elevai Empower topical exosome post-procedure product. Of course, the healing from these procedures doesn't end when the client gets out of the chair, right? They still have to go home and continue to recover. And just as when you're done with a big meal and you might be full, you still are going to be hungry the next day, right? There's a limit to what our cells can take on at any given time. And so rather than just flood the cells with one bolus of exosomes at one time, being able to use them topically at home allows them to be used over a longer period of time. And so you can see here in the middle, this is our topical take-home procedure, post-procedure product. And this can be used every single day, and we call it Infinity. And with these two products, we actually launched the company on the NASDAQ under the ticker ELAB back in November, with more coming soon. So first, I'll just take a quick step back here. I think a couple of years ago, when I started really traveling the world and speaking on exosomes, I'd go to a lot of aesthetic conferences, and people would say, "Oh, exosomes are very new. They're in their infancy. You know, we don't really know yet what's going on." And so I like to point out that since 1983, when there's arguably the first use of the word exosomes as we use it today until now, there's been over 200,000 publications talking about exosomes. And if you look specifically at human mesenchymal stem cell exosomes in the skin, that represents nearly a quarter of those articles. And this is actually a faster ramp up than human stem cell research, which I was privileged to be a part of. And so to say this is a hot topic is sort of an understatement. How did we get here? I think the other thing to think about here is why exosomes? We hear about this technology and that technology and why this is the new best thing ever. But I think if we really kind of look back in time, you'll actually understand that stem cell exosomes, exosomes from human stem cells, are a natural progression in this sort of timeline, and that this is not just some fad or some passing phase, for a number of reasons. So if we go back to the 1970s, copper peptides were devised in 1973. We actually have copper peptides in our daily product. This is a great peptide, and there's been a lot of great peptide work since then. But a peptide is really just a short chain of amino acids, like a truncated protein that is meant to do the job of the full-length protein. It's smaller in size, so it can often absorb better, but there are limitations and issues with peptides, and it's really just a small synthetic form of something larger that's natural. In the 1990s, we started to see growth of recombinant growth factors. Recombinant meaning that we've taken an organism, usually a bacteria, and genetically modified it to produce a specific protein, a specific chain of amino acids that we want. And I put growth factors here because of the fact that, as we've been trying to crack the code on youth, early attempts were really about how do we, basically copycat what is going on in young skin. And one of the things that was noticed early on is that there's a number of growth factors in young, healthy skin, and that they're producing more growth factors than aged skin. So you had things like epidermal growth factor, or EGF, being put inside of a E. coli or bacterial vector, and then that bacteria is cultured in the laboratory. And because bacteria are dividing about once every 20 minutes, compared to a human cell, mammalian cell, about once every 24 hours, you could get exponentially more growth factor from these bacterial vectors that were genetically modified. And this is really exciting, really cheap in comparison. Unfortunately, what is not often highlighted is that bacteria are not like human cells. They don't have an endoplasmic reticulum. They don't have a Golgi apparatus. And this makes it so that they don't fold the proteins correctly. They don't put the right cap and tail sequences on them. They don't have the right glycosylation tail, which affects their half-life, and a number of other things. So often these sort of proteins or peptides or growth factors made in these recombinant vectors are recognized by the human cells, by the human body, as a foreign entity because it is made in a bacterial cell, and your immune system recognizes that. So there's some limitations here. As we moved into the 1990s, by 1995, there's a company called Isologen. They were taking a hole punch biopsy from behind your ear where there wasn't a lot of sun damage to skin. They would grow your skin out in the laboratory and then inject the skin cells back into your face strategically. And that worked very well. But basically what's occurred since is that you had the FDA and other regulatory bodies saying you can't take cells from a patient, put them into the laboratory, and then put them back into the patient. That is more than what is termed minimal manipulation. And you have to, only do minimal manipulation. And so that was stopped. 1996, we saw uprising in hyaluronic acid. This is something, again, that we use in our products of various molecular weights, depending on the use case. And then in 2001, we saw TNS serum, or the start of fibroblast conditioned media topical products. So instead of taking the actual fibroblast cells or other skin cells and putting them back into the face, the idea was to grow them in the laboratory, take the liquid food that the cells are growing in that contains a lot of what these cells are excreting or releasing, and then use that liquid as a ingredient in a topical. And so now you went from injecting cells to now applying a topical that was conditioned by these cells. That was in 2001, so over 20 years ago. By 2010, we started to see the rise of platelet-rich plasma, what's commonly termed the vampire facial now, popularized by many celebrities. And we also saw a shift from, in 2001, in the US, there was a lot of human stem cell research that was banned or limited. By 2008, that was overturned. And by 2010, you started to see a lot of doctors in the US and around the world doing stem cell injections. And just like we saw back here in 1995 with Isologen, the FDA stepped in and said, hey, look, you cannot take cells and inject them into patients outside of a medical clinical trial. This is not allowed. And so just like before, when we were taking skin out and growing it in the laboratory and then using the liquid to create a product, the same thing happened in the 2010s, where stem cells were grown in a laboratory. And as they're growing in their liquid, their growth media, those cells are conditioning the media, and that conditioned media became an ingredient. And the same was also tried with PRP. And so this was a way so that you're not putting live cells in or on a patient. And the FDA said that's fine, and that's been around for quite some time. In 2018, there was a push towards exosomes. And so exosomes are a subcomponent of conditioned media. And so there's something that's naturally released by cells, and not just stem cells, but pretty much every cell type is talking to each other with other cell types using exosomes. But out of everything that the cell releases, what the data has shown over the last 15, 20 years is that the exosome portion is the most important portion, and that this is really what's driving the change. And so in 2018, you started to see people say, okay, well, if I can't inject stem cells, I'm going to go ahead and inject the exosomes. And again, the FDA stepped in and said, no, 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 you cannot be injecting something that is not clinically approved, that has not been through clinical trials. And so we saw a shift from what I'd call first generation exosomes, which were initially made for injection purposes, to a second generation where they were stored slightly better. They didn't need a freezer necessarily, to now third generation, where now we're talking about stem cell exosome topicals. So again, we're back in this realm of what the regulators like to see, where we have a topical cosmetic product that is derived from lipids and growth factors and things that we know work from all the history before, but now we've just made it that much better. And so, what are exosomes? I would think by this point, you probably have heard enough about it, so you can probably answer this question fairly well. But most simply, an exosome is an envelope. It's an envelope that is containing a message. And just like an envelope or a piece of mail that you get at home, the quality of the message, the type of the message, it depends a lot on the author of that message. It depends on the cell that is making that exosome and what it's putting into the exosome. And so the goal now is not just to grab any exosome, but we want to grab the exosomes from the right cell type that have been treated in the right way, that represent the conversation between cells or the messages between cells that are of interest to us. And so it's very important to understand that exosomes from one source or one company are not the same as another, and that there can be very broad differences depending on how they're made, what cell types are used, and not just what cell type, but how that cell type is treated. So I won't spend too much time here, but I do want to just give everybody a little bit of a reminder here. And of course, we all have a body. Our biggest organ is the skin, a multicellular organ.
You have 10 minutes more, doctor.
Okay, thank you. So just to zoom in on the single cell level, every single cell has a nucleus, which of course is where the DNA is stored. DNA is transcribed into RNA, which is translated into protein. And it's this RNA and protein that we find in the exosome, protected by a lipid bilayer. So you can think about RNA and protein as these messenger molecules that, when they're not protected, often have a limited half-life. But when they're protected in this lipid bilayer, they can be protected and they can get around the body. They can maintain their potency. So what does this mean for aesthetics? Well, at the end of the day, what most things are doing in an office is to create a controlled micro injury. And so there's a few slides here from a paper I've listed below where you can see we've grown some cells in the laboratory. This is a standard scratch test. And when they add exosomes to those, you see that artificial wound closing faster than in the control group without exosomes. And the same is repeated here with actual skin. And so effectively what's happening is you add exosomes topically in a wound model, you see this wound closing faster. So we know that these exosomes are playing a role in modulation of the healing process in some form or fashion. And this is, again, slightly different depending on which cell type you're using. We're focusing here on mesenchymal stem cell exosomes. And really what we're trying to speed up here is the natural healing process, which is a 4-stage process. This is well documented in the literature. And effectively, if you look below these 4 phases, you can see the cell types that play a role in healing. And this is important mainly because I think there's a lot of talk on platelets, which are here at the front end and only play a role in the very beginning. There's various products that have been from fibroblasts, which are kind of here in the middle. But if you look along the bottom, stem cells actually modulate all 4 phases of healing. So really what exosomes are about, or at least stem cell exosomes, are about moving us through these 4 phases effectively, efficiently, and quickly by making sure that everything that's needed here is provided. So exosomes, as I mentioned, are everywhere. They're in all these different biological fluids. We found them in pretty much every biological fluid. So it's really about trying to grab the conversation between specific cells. You know, what kind of conversation do we want to grab? What cell do we want? And so cell source becomes very important. And these are the sort of 5 pillars that I suggest you look at when you're looking at an exosome product. You can get your stem cells from various sources, and you can even get exosomes from non-stem cell sources. Elevai, the company that I co-founded, focuses on Wharton's jelly mesenchymal stem cells. This is from the umbilical cord. These are from full-term healthy births from consenting mothers that have been very well tested for viral and microbial contamination to make sure that there's none of that. And these are effectively age 0. And this is important because other stem cell sources like bone or fat, you might have an impact by that person's lifestyle, their age, or their disease state on the actual stem cells that are being used to produce exosomes. And as this recent paper shows, again, younger cells produce better exosomes.
You have 5 more minutes.
Okay, thank you. So just want to give an overview of our precision regenerative exosome technology. This is our how our actual process differs. This is what we call our source to skin platform. And this is really where we're controlling everything from the stem cell isolation until we get the exosomes into the packaging that goes to you and then eventually onto the client's skin. And we think that this is very important to control because there are a lot of places in the middle where damage can contribute to degradation of exosomes. So everything we're doing is really about maximizing production and minimizing damage to exosomes. We also do not use any animal-derived products or animal testing, and we feel this is very important because there are a number of animal-based diseases that can make their way into the process, and we know that there are various companies out there that use animal-derived products in the creation of their products. A big question that we do get a lot is stability and preservation. I think there's been this expectation from generation 1 exosomes that you have to freeze exosomes or do something similar to preserve them. But you need to remember that our bodies are 37 degrees centigrade. This is the normal temperature of the human body and the temperature in which exosomes are produced in your body right now. Your body is currently full of millions, if not billions, of exosomes, and they're floating around in your bloodstream and various biological fluids at this temperature. More than that, the original exosome research was done using ultracentrifugation, exposing these to 100,000 G-forces, successfully isolating them. And this is about 10 times more G-forces than they're using currently to launch some satellites into space using a centrifugal system. So it's really a huge amount of G-forces, which really shows how stable these exosomes are. And for those interested, you can actually look into an equation called Coiter's equation, which explains the physics behind this. So talking about generation 1, 2, and 3 exosomes, the first ones that came out were really freezing the exosomes or just throwing them in the freezer, a fairly lazy way to preserve. They didn't have any cryoprotectants, and these were really designed for injection. As folks tried to ship these around the world, they found that using dry ice, you could only freeze things for a limited amount of time. And so they moved to lyophilization, which is a fancy word for freeze drying. And the problem with freezing and freeze drying is that you've got a lot of water content in your cells and therefore a lot of water content in the exosomes. And we know that as water expands, as water freezes, it expands, and of course it damages the exosome envelope. And when that envelope is damaged, the contents become unstable. And so by using the latest in biomimetic hydrogel research, we keep the exosome stable at a room temperature and protect them from oxidation and UV damage, and effectively provide something that's easier to use and it is keeping the exosome stable and intact. The other thing here is around ease of use. Again, using this topically is not only what the regulators like to see, but it means you have no reconstitution required. We're not giving you something that needs to be mixed together. It's ready to go. A product on the left here is our in-office product. The one on the right is the at-home product. And just going to go through a couple quick case series so you can see what's possible here. This is a microneedling with 1 hour apart from these pictures on left to right. This is a skin pen microneedling. You can see as, again, it moves across. This is 1 hour difference. This is taken with the Canfield Visia system. This is another one with the Canfield Visia, and you can really see these are 1 hour apart, again, after application of our Empower product. You can see how much redness is reduced in a rather short amount of time. Now, of course, RF microneedling is becoming more popular, and you get even more redness there oftentimes. We already saw this patient. This is a different one using the Morpheus 8 system. You can see really, especially in this picture on the right, the difference in redness over just a course of an hour. So it really brings down that redness, and often clients report much higher satisfaction and less discomfort. This is after a vascular laser. This is someone who came in with rosacea. And again, you can see an hour apart, quite a drastic improvement in the redness of her skin after a single application, 1 hour apart. And so while those are interesting to see and it helps with social downtime, I think, again, it's really interesting is the ability to take this product home and to use this over time. This one on the right is 4 weeks topical application only, no treatment. And this is at 8 weeks. Again, you can see this dramatic reduction in redness with just 2 times daily application. And then not only is this great on redness, but we have seen with pigmentation similar results. This is after 16 weeks. You can use this continuously every day. This has not got any hydroquinone in it. You don't need to cycle off of this. And really, this is about trying to nourish and support the skin rather than cover up issues or use chemicals.
You have used all your time. Let's hear the conclusions.
Yes, that's it. I basically just wanted to point out that I think this is a system that was developed for post-procedure care, but it does extend into daily care. And really, when you're doing an expensive set of treatments like a laser, microneedling, RF microneedling, these sort of products can really help to optimize the patient's investment, limit their social downtime, encourage them to come back in for follow-up treatments. And overall, it's very gentle while being powerful at the same time. For those interested, I would suggest scan this QR code here, follow us. You can reach out to Elevai via Skin Sauna or via our website.
Thank you, Doctor. This was a very interesting lecture.